All right, folks, welcome back. Happy Monday. So I'm not sure if any of you have been on Canvas yet today, but the new module opened up, and there's only one topic on the agenda this week, but it's going to be two separate lessons. Okay, so the title for today is Piecewise Functions Day 1, and then we'll do Piecewise Functions Day 2 later in the week. And you'll see the homework is also separated that way. So after today's lesson, you should be able to do the homework entitled Piecewise Functions Day 1. So let's start with the definition. Definition. A piecewise function is defined differently dependent on its domain. And if you remember, domain means x values. So there's really four different things that we have to do with piecewise functions. We're going to touch upon three of the four today. The first thing is called evaluating a function. Okay, evaluating piecewise function. So a piecewise function has multiple lines associated with it. So when I write f of x, you want to leave a little space because there's going to be this kind of bracket thing that's going to hold all of the lines of the function together. And so the first line of the function, I'm going to make that 2x plus 3. Second line will be, let's say, x squared minus 4. And then we'll do 5 minus 4x as the last line. Now I'm going to put a comma after every expression because the comma, after the comma, I'm going to have the domain for that piece. So for the first piece, I'm going to say that that is defined when x is less than -1. For piece 2, that's going to be compound inequality. -1 is less than or equal to x, which is less than, let's say, 4. And then the last will be x is greater than or equal to 4. I find it helpful to work in colors for this topic. So if you have, colored pencils at your disposal, maybe you want to use them. Some people don't care, but I'm going to set it up with colors. So let's do, I'm just trying to tie everything together here. So all of this up here is tied together, okay? They give you the value of the function, and they tell you when it's that value. And then I'm going to go through, I'll make this one purple. And then I'll make the last line green. And so now the question is, I want to know the value of the function at certain locations. So I want to find out, well, what's f of 0? What's f of -4? What's f of +4? What's f of 10? what's f of 3? Okay, basically 5 different problems here. And the trick is you look at the number you're evaluating at, and you decide which one of these inequalities it satisfies. It's only going to satisfy one. Okay, it's not going to satisfy all of them. It's not going to satisfy 2 of them. It's only ever going to satisfy one inequality. So 0, it's actually the middle one, right? It's between -1 and 4. 0 fits in there. So you're substituting 0 into this x squared minus 4. We'll put here, use x squared minus 4. And you plug 0 into that and see what you get. And that comes out to be -4. And then you move on to the next one. The number -4, where does that fit? Which one of these 3? It should be the top one, right? -4 is less than -1. So you're going to use 2x plus 3. And substitute the number into that. And that comes out to be -5. The next one, I'd like you to put a little star by this one, because people flub this one a lot because they think it's on both, right? You see a 4 here, you see a 4 here, so they do both, right? It's never both. It only fits in one of them. It doesn't fit in this one, the purple one, because 4 is not less than 4. And so it doesn't work for that. It only works for the green one. 4 is greater than or equal to 4. So you have to use 5 minus 4x. So substitute into that. 5 minus 4x is 4. So that's 5 minus 16, which is -11. Right? 10. 10 also is on this, right? It also satisfies this inequality. So you use 5 minus 4x again. And that comes out to be -35. Last one is 3. 3 is in this middle piece. So you're going to use x squared minus 4. So 3 squared minus 4 is 5. Okay? So that's how evaluating a piecewise function works. So I'm going to give you one to try now. Another evaluation. I'm going to erase this up here. I'm just going to start writing it up here. So it's the same directions. I'll call it, this time I'll call it g of x. Again, I'll have it have 3 different pieces. Let's make the first piece -3x plus 1. We'll make the second piece 10. And the last piece 4x minus 3. And I'm going to give you the domains. So for the first piece, I want x is less than or equal to -5. Second piece, -5 is less than x, which is less than 4. And then we'll do x is greater than or equal to 4. Okay, and now I'm going to ask you to do, let's say g of -10, g of -5, g of 0, g of 4, and g of +10. And I will give you, I'll give you 2 minutes Set the timer. 2 minutes. Okay, so I'm just going to highlight again what is tied together. I'll make this purple. I'll make this blue. And then I'll make this one orange. So now you're given a value of -10 to evaluate. The -10 belongs in one of these three inequalities. It is in the top one. -10 is less than or equal to -5. That means you have to use the -3x plus 1 and substitute the number into that. So you should have got 31 for that. -5, again, it satisfies the top inequality, right? It's not a part of this because there's no equal sign on this second compound inequality here. So it's in the top one. You're going to use the same -3x plus 1. That should give you 16 for that. 0 now. 0 is in this middle inequality. It's between -5 and 4. There's nothing to calculate. You notice this is the first one now. There's no variable here. This is called a constant piece. Right? Constant pieces have always the same output. So in this case, it's 10, the output. You don't even have to think about doing anything in terms of a calculation. 4 is on the orange one. 4 is greater than or equal to 4. So you would use 4x minus 3 for that. Gives you 13. And then the number 10 for the last one. 10 also satisfies this last inequality. So you would use 4x minus 3 for that. And that gives you 37. Right. So we're going to now have to do some graphing. Okay, graphing. So we'll do a new function. So let's call it f of x. We'll make it 3 lines. Top line is going to be, let's do negative 2x plus 1. Second line is going to have a value of 4, constant. And then the last line will do 3x minus 7. Okay. And now I'll give you the domains. The first domain for the first piece will be x is less than, let's do negative 3. Second piece we'll have going from negative 3 less than x. I'll do less than or equal to x. And less than 1. And then the last piece we'll do x is greater than or equal to 1. Now, when you're doing a sketch, there's a lot of information you have to gather. This is not going to be a quick problem. I'm going to have 3 sets of information. Okay, give yourself some space. You're going to have information for piece 1, for piece 2, and for piece 3. You're going to need 2 ordered pairs for each piece. Again, I'm going to color code this. I'll make the first piece orange, second piece purple, and third piece we'll do green. Now, before you do any work, it is helpful if you mark down what the piece is going to look like. You don't need any math to do this. You look at the inequality and think about what it would look like on a number line, right? So x is less than negative 3, that would be a ray. Starts at negative 3 and it goes to the left forever. So your piece is going to be some sort of array for piece 1. For piece 2, it's a compound inequality. If it's a compound inequality like this with x in the middle, that means you're going to have a start and an end, which means it's going to be a line segment. Okay. And then piece 3 starts at 1 and goes on forever. That's what array does. It starts somewhere and goes on forever. So these are your 3 pieces. Now you have to start gathering information. So array, what does it do? It starts somewhere and then it goes on forever. But for you to get an accurate depiction of where it's going, you need a point that it's going to eventually go through, okay, to give direction. So I write start point and a through point. Now, it starts at the number that they gave you. They gave me the number negative 3 for piece 1. You have to pick a through point. So you have to pick another number that satisfies this inequality. So another number that is less than negative 3. I would choose the next integer over, which would be negative 4. Now, when I write my work down, I always circle anything that I came up with on my own. That way, when I look back later on, if there's an issue, maybe it was because I picked the number wrong by accident. Okay? The outputs, this is what you have to do in terms of what the last example. So we're in piece 1, you're using this negative 2x plus 1, and you're using it twice. Negative 2x plus 1, negative 2x plus 1, right? And I'm substituting these numbers into the function expression. So I substitute negative 3 in, and then I substitute negative 4 in. and I see what I get. So the first one I get 6 plus 1 is 7. That goes up here. The second one I get 8 plus 1 is 9. That goes on here. Now there is one other thing you have to declare before you can move on to piece 2. And that is whether these points are open or closed. So the start point, right? If you look at the inequality, there will either be an equal sign under there or there won't be. And there isn't one right now. So that means, this is kind of like what we did last week. That means that would be an open circle. Through point, I'm going to write down here. When you pick a point on your own as a through points are always closed. Through points are always closed. So this thing is closed. Now I go on to piece 2. It's a segment. A segment has a start and an end. The start and the end numbers are tied to this inequality. It starts at -3 and it ends at 1. Now I would normally do my calculations now under here to get my outputs, but you'll notice that piece 2 is a constant piece. So there's no calculations needed here. If you're on piece 2, then the output is always the number 4. That's what it says. I'm just going to put 4s right there. Now you go back for open and closed, you look at the inequality. The compound inequality, the first symbol has an equal sign under it for the -3. That means this will be closed. And then for the 1, there is not. So that would be open. I move on to piece 3. Piece 3 is array. For arrays, you're going to need a start point and a through point. Start point and a through point. The start point they gave me is 1. I need to pick a point that is going to go through, right, something that satisfies this inequality. So a number that is greater than or equal to 1, I would pick 2. Circle that because I picked it on my own. And now I do my calculations for the output. I have to use 3x minus 7. 3x minus 7 for this. And I'm substituting in 1 and then 2. And so this one gives me 3 minus 7 is -4. And then 6 minus 7 is -1. Now it's a matter of just giving the open and closed on this. The start value has an equal sign under there, right? So that is going to be closed. And then through points are always closed. Doesn't x have to be less than -1 for the second piece? Less than -1. I don't see that. Now you got to make a graph. Now, when you need to look at all these numbers and figure out how large you need to make your graph. You got to deal with the number 9. So I would tell you make a graph 10 by 10. I'll do it up here. You're going to have to do it, I don't care if you do it freehand on paper, on notebook paper, or if you feel like you need to go out and get graph paper, I guess you can do that. But I'm okay with you just freehand drawing it. I'll give you a minute to set that up. So we'll start putting the pieces on. Okay. If you have everything written down here, some people find that they don't need to write everything that I'm writing. Do what you got to do, I guess, but you're going to need to at least give me the 2 ordered pairs from each piece that you're using. Okay. If you don't feel like writing start and through, or you don't feel like writing open closed, that's on you. But I'm going to need to at least see 2 ordered pairs for each piece as your supporting work. So this first piece starts at -3,7 with an open circle. -3,7 would be right about here. And then it goes through -4,9. -4,9 is out here. Okay? And it's going through that point. So it's starting at the open circle and going through -4,9. So it's going up and to the left. And it's a ray. So you should put an arrowhead on the end of it. Piece 2. It's a segment. It starts at -3,4. -3,4. Right about here, closed circle. And it goes to 1,4, open circle. And you'll see there when you connect them that it's a horizontal. Okay? Constant pieces are horizontal line segments or horizontal rays. But it's going to be horizontal for anything that's associated with a constant. On to piece 3. Starts at 1, -4 closed. And it goes through 2, -1 closed. Okay. And that's your ray. So make sure there's an arrowhead on the end of that. And that's it. But like I said, if you think you're going to sketch one of these in 30 seconds or a minute, you're mistaken. Right? You have to gather a lot of info before you can make the sketch. I'm going to let you try one. Unless there's any question on this before I'm going to erase the function. Through point, and you don't need to think about it. It's closed. But otherwise, you're looking at the inequality. So right here, this -3, right? The reason I got that -3 is because it's right here. Okay? So you're looking at that inequality, and you're looking at the symbol. If the symbol has an equal to sign underneath it, it's closed. If it doesn't, which it doesn't here, then it's open. That's why I wrote open. If you look at piece 2, you have one of each, right? You have the -3, that's part of this right here. So you look at that has an equal sign underneath, that's closed. Then you look at for 1, that would be these two. X is less than 1, there's no equal sign under there. So that's why that one is open. All right. I'm going to let you try one of these. I'm only going to make it 2 pieces because I'm keeping my eye on the clock here, and I know there's still one other thing we have to do after this example. So let's call it sketching. So f of x equals, again, two pieces. You're going to do negative. Actually, no. Let's do 3x plus, do 3x plus 8. And let's do negative 2x plus 6. And we'll do the top one, x is less than, say, negative 2. And then this one we'll do x is greater than or equal to negative 2. So again, it's 2 pieces. And I'll give you 4 minutes to do the whole thing. So come up with your info and then make a sketch. 4 minutes. No, this is not the third thing. We got one other thing to do after this. But I'd say this is the thing that takes the longest. Okay. So I'll do purple and blue. So you'll notice that both of these inequalities, these aren't compound inequalities, right? So it just starts somewhere and goes on forever in one direction. That means that both of these pieces are arrays. So piece one is array as a start point and a through point. This one does as well, so I'll just write that down. Both rays. So the start number they gave me for piece one is -2. I need to pick a number that's less than -2 as my through point, so I'll pick -3. And now I need to substitute those numbers into the expression for piece number one, which is 3x plus 8. So I substitute those in. I get back 2. And then I get back -1. The inequality that they gave me does not have an equal sign underneath it. That means the start value is open. And the through point is always closed. I can now move on to piece two. Start value for that is -2. The through point, I need to pick a number that's greater than or equal to -2. I'll pick -1. These values get substituted into the -2x plus 6 expression. So -2, -1. So the top one gives me 10. Bottom one gives me 8. I look at my inequality. The one that they gave me has an equal sign under it. That means the start point of the ray is closed. And then through points are always closed. So for this one, right, so -2 for piece one, I look at that inequality. There is nothing underneath there. That means open circle. If there was an equal sign underneath there, then this would be closed. Right, so you're looking at the inequalities, the symbols. Does it have a equal sign underneath it or does it not? Now to fit these numbers, you're going to have to go up to 10. So we'll make a graph go up to 10. First piece is in purple. Starts at -2, 2, open circle. And it goes through -3, -1. Closed. It's going down and to the left. Piece two starts at -2, 10, closed. And it goes through -1, 8. Whoops, I'm on the wrong side here. -2, 10. And -1, 8 is about here. And so that's the picture you should have. Make sure you have arrowheads at the end of your rays. And now we have one last thing we have to discuss. And so it's a little steeper. Thank you for that. Any other questions? Okay. So the last thing we have to do is an application problem. We're not going to graph it. We're just going to set it up. So we're going to title this shipping costs. So if you were to walk into, like UPS store or something like that, and you want to send a package, you usually have some sort of a chart on the wall that tells you, how much it's going to cost you to send your package, usually based upon weight. So we'll do it that way. So we'll make a chart. We'll do so if the package weighs less than, let's say, 20 ounces, it costs you $4.50 to send it. Let's say then the next line is, say, greater than or equal to 20 ounces, but less than 40 ounces. Let's say that is, say, $7.25. And then we'll do greater than or equal to 40. But less than 72 ounces. We'll make that 1075. And then finally, greater than or equal to 72 ounces. $17. Jack up the price. So the idea here is this scenario is modeled by a piecewise function, and I want to write it out. So we have, we can use C of X for cost, C of X. Okay, and this thing is going to have 4 lines. The values of the function are what it costs you to send the package. So it would be $4.50, $7.25, $10.75, and $17. The domains is what you have to take a moment and think about based upon what they told you. The first one is if it weighs less than 20 ounces. Now, this is one where I might take a point off of your paper if this were like a quiz question or a test question, because in this context, even though it says less than 20 ounces, you need to know that it's impossible to mail something that has negative weight. And you can't actually even mail something that has 0 weight, right? You can't. It needs to have some sort of a weight for you to mail it. So on this actually has kind of a hidden boundary at 0 that you'd have to put in there. It can't mail negative weight. The rest of them are pretty straightforward. You've got greater than or equal to 20, but less than 40. So these are now compound inequality. So 20 is less than or equal to X, which is less than 40. Next one goes greater than or equal to 40, but less than 72. And then the last one, greater than or equal to 72 ounces. So X is greater than or equal to 72. Okay? They don't have a limitation on it, which in reality they probably do. But for our example here, we'll assume that if you go in with a package that's heavier than 72 ounces, then you can mail it for $17. Right? And this is just saying, where really I wouldn't take off, but if you were, writing this out for someone, you would say where X is the weight of the package. In ounces. So there is a problem similar to this on the homework. So you should only be doing piecewise functions day 1 homework. Okay? There's one other thing I just got to mention, and that is, well, it's a pretty big thing. We have our first quiz this week. If you looked at the modules in Canvas, you should see it there. Marking period 1, quiz 1. I originally was going to do quizzes in class during our live time. I'm not going to do that. So it's going to be in Canvas. If you tried doing that silly practice quiz I put on last week, it's going to look kind of like that, but it's going to be real questions this time, and this time it's going to count. It's going to be timed 20 minutes. If you get extra time, I already have it built in there for you, personalized. So you'll see that in there when you go in. But once you start it, you can't stop. So you need to put 20 minutes aside. I'm going to tell you when it opens, okay? So it's going to be open on Thursday, this Thursday, the 24th. It's going to open at a minute after midnight. And it's going to stay open until 9 p.m. So you're going to need to put aside 20 minutes or a few more minutes, right? If you're exercising your extra time, that you can get that done in that window, okay? If you have a problem with that in terms of your schedule, and email me and we could discuss it. But if you just don't take it, it's going to be a 0. And we're only going to have one of these every week. So you're talking about it's going to weigh down your grade if you got zeros piling up next to your name. So if you're somebody who has a planner, or even if you don't, I'd put this in your phone today and make sure that you take care of it on Thursday. All right. The video for this will be up probably, in the early afternoon. You have 2 homework assignments this week. It's labeled when you go look at it, Piecewise Functions Day 1. That's the one you should be doing today, okay? And that's about it. I'll be at my conference period, WebEx, from 1 to 1:30 every day this week. I wasn't there last week because I had to go to the high school and get some stuff. So, but I'll be there 1 to 1:30 if you need me. Otherwise, you are free to go. Have a good day.